All right, everybody, Mr. Berry back here again. Let's go with the first example here. We're going to actually make an equation from a picture we have up there, but we'll also go ahead and label certain things that we have on that picture. I tried my best to make connect all the dots and make the absolute value function really pop there. You can see the letter V. You can see that it's an absolute value function. And right next door to it, I have our parent function, which again, we're basing everything off of. What do I want to do in order to be able to get this equation here? Well, I have my general form of an equation. It's y is equal to a times the quantity x minus h, and that's all in an absolute value, plus the k on the back end here. We know that the hk stands for vertex. We know that the a is the slope to the right of the axis of symmetry. Those are things that are constant for us in these problems. So let me go ahead and find a couple things here. The first thing I always want to figure out if I have a picture is what is the vertex. Vertex here would be 1, 2, 3 for the x value, up 2 for the y value. So my vertex here is 3, 2. That's my vertex. All right. The axis of symmetry is on that vertex, and it's an imaginary line that goes vertical through the vertex. So let me go ahead and just draw a dotted line that's not officially there, but we go ahead and use it just to help the cause. And we can see here that the dotted line that I just drew would be the axis of symmetry, and that line is x is equal to 3. I'm using that axis of symmetry in order to help me count out the slope to the right of the mirror. So there's two slopes here, one to the left, one to the right. We're concerned mainly with the one to the right. And as I count to the right of the mirror, I'll start at the vertex and I'll go up 1 and to the right 1, up 1 and to the right 1, up 1 to the right 1, up 1 to the right on 1, so on and so forth. And I've always said that the slope right there would be up 1 and to the right 1. We can know that we can simplify that, and that our slope there would be 1, which we know is significant because our a value is going to be that slope to the right of the mirror. So I have my vertex here is 3, 2. I have my a value, that would be equal to 1. I'll go ahead and plug things in. Now when I plug things in, again, the most trickiest spot in this function, in this common equation, is when I have a very common used equation. It involves a minus sign there. All right, so I have to be careful when I plug things in. I like to always use parentheses when I plug things in, especially early on when I'm teaching you. Of course, if you pick this up really, really quickly, you don't need to use parentheses. But let me go ahead and plug things in. I know that my y value and the equal sign and the absolute value and the x and the minus sign and the other absolute value bar and the plus sign back here, those things aren't going to change at all ever when I plug things in. Let me go ahead and start to plug things in now. My a value was the number 1. We'll stick that in the front where the a was at. I'll go ahead and I'll put the letter h in. The h and the k come from our vertex. H is the number 3. K is the number 2. H and k take on x and y for our vertex. So h is the number 3. Y is the number, k is the number 2. That stands in for our y for the vertex. Now, do I really need those parentheses? I'm not really sure on this particular one. All the numbers here are positive. You'll see what I mean here in another video. So if I can clean things up, let me go ahead and clean things up. What I'd like to say here is that I have y is equal to. I'm going to end up multiplying 1 times the absolute value. And when I times 1 times anything, it keeps the identity there. So there's an understood 1 there for now. First couple videos, I'll put the 1 in front of the absolute value. Then I have x minus 3. Minus 3, I'll just leave it like that. And then finally I have plus 2. The one thing I want to point out here is let's go ahead and just compare the two graphs now. So how did this graph change from our parent function? How did that graph over there change from our parent function? Well, the vertex moved a little bit, right? The vertex moved a little bit. We'll put all the information about the vertex over here. The vertex moved. Here it was 0, 0. We know that it moved a little bit over to the right and a little bit upward. So the whole graph moved a little bit to the right and a little bit to the left. A little bit to the right and a little bit up compared to the parent function. It moved up and to the right when we compare it to the parent function. The other thing I want to make sure that I check out here is how did the slope or our a value change the graph? And we have the same exact slope here. We went up one and to the right one off to the right side of our axis of symmetry. So our slope didn't really change anything when it came to the width of the graph. So our width stayed the same. Compared to the parent function over there. We can pick out a couple other pieces of information just for practice sake. For instance, this graph is going upwards. The graph is pointing up. We know that this line is traveling all the way to the left and upwards. We know that this part is going all the way to the right and upwards. So if we had to do domain and range here, we could do domain and range. Domain, all the way to the left, all the way to the right, everything in between. We're going to have our negative infinity is less than x is less than positive infinity. Our range, we have our vertex right here as a minimum, which means we have everything above it, nothing below it. If we wrote words out here, we would write the word up. There's the word up, which means we hadn't written the word down. Our y value here is the number 2. Our y value here is the number 2. So we could be above that number 2, or we could be at that number 2, or we could never go below that number 2 when it comes to the y values. Nothing is below it. It's a lot of information. We'll continue to practice, but we can gather a lot of information just from one small picture based upon the fact that we have this absolute value function common, and we can definitely always compare it to our parent function.